So let's take one last example and illustrate something with exponential functions. This is what's called a radioactive decay application. In this application, the main thing about radioactive decay, most people think of something called half-life. What is a half-life? Well, that's the amount of time it takes for some radioactive isotope, and most people think of things like radioactive uranium or radioactive carbon or one of those other unstable isotopes of a compound. And it takes amount of time for that to decay. That is, it becomes a more stable isotope by either gaining an electron or losing an electron or something like that. All right. So here's an example of one. Let's say it takes about 24,100 years for radioactive plutonium-239 to decay to half its original amount. Well, here's a model for this decay. It goes like this. It says that Q0, whatever the initial amount is, Q0, times the base 1/2 raised to the T divided by 24,100, right, is going to give us half the initial amount. Well, you can see how this works, right? Because if we were to actually put in T equals 24,100, we would find the amount would be half of what we originally started with. So if we had an initial amount of 16 grams, what would that mean? Well, this 16 grams right here is the amount that we get at time t equals 0. Right? So what that means is for our function, we could say Q at time t0 would be equal to Q0 times 1/2 to the 0 over 24,100. Well, 0 divided by anything is 0. So that 16 grams is our amount Q0. And so our model here, Q, the amount of radioactive isotope, is equal to 16 times 1/2 raised to the T over 24,100. All right. So the next question says, well, how much will be present after 75,000 years? So what we're going to do is we're going to figure out that amount by substitution. We're going to take 16 times 1/2 raised to the 75,000 divided by 24,100. Now let's see how much we can figure out that would be. Well, this is where we're going to need a little bit of help with our calculators. Of course, thousands, right, those zeros, those are going to divide out. So it's like taking 750 and dividing that by 241. So let's work that out with our calculator. If we took 750 and divided it by 241, we would get 3.112. All right, so that's like saying here 16 times 1/2 to the, what do we say that was, 3.112 power? 3.112 power. All right, so using our calculator, we can take 1/2, we can raise that to the 3.112 power, and then multiply that amount by our original 16 grams, and here we go, 1.85. So we're going to say that, well, Q would be equal to approximately 1.85 grams of that radioactive plutonium isotope left after 75,000 years. Well, there we go.